Hey everyone, welcome back to Cracking the GRE Math Subject Test, Precalculus chapter. We're on question number 13. This question is a little bit tricky. It tells us that when a polynomial p of x is divided by x minus 1, it leaves a remainder of 1. And when it's divided by x plus 1, it leaves a remainder of minus 1. And then we're asked what the remainder will be when it's divided by x squared minus 1. So the way to approach this problem is to first of all write in equations what the problem says. So what does it mean for when p of x to be divided by x minus 1, it leaves a remainder of 1? Well, it means that p of x is equal to x minus 1 times some other polynomial, call it q1 of x, and then plus a remainder of 1. That's what that means. And similarly, we can write that p of x is equal to x plus 1 times some polynomial plus a remainder of minus 1, so minus 1. And then we're asked what the remainder is going to be when we divide by x squared minus 1. So we're asked if we write p of x is equal to x squared minus 1 times some polynomial, say q3 of x, what's our remainder going to be? And remember that when you divide a polynomial by another polynomial like x squared minus 1, then the remainder could either be a constant, or it can be a polynomial up to with a degree less than the degree of the polynomial that you're dividing by, the divisor. So in our case, since we're dividing by a second degree polynomial, the remainder could be a first degree polynomial. So we'll just represent all of the answers as all of the possible remainders as ax plus b, where a could be 0 and b could be 0. If a is 0, then the remainder is just a constant, and if a and b are 0, then there is no remainder. The remainder is 0. Okay, so now we've written out what this problem is asking us, and now what we can do is plug in p of 1 into the first equation. And that way, this part will drop out because 1 minus 1 is 0, and we'll get that p of 1 is equal to 1. Similarly, we can write p of negative 1 in the second equation, and that means that this first part will drop out because negative 1 plus 1 is 0, and we'll get that p of negative 1 is negative 1. And now we can use this information to plug into the third equation, because now we'll get that p of 1, which we know is 1 from the first equation, is equal to, now we'll plug it into the third equation, we'll get 0, because 1 squared minus 1 is 0, so this whole part will drop out, and that will equal a times 1 plus b. And for p of negative 1, well, from the second equation, we know that that's equal to negative 1. And if we plug that into the third equation, again, we'll get 0, because negative 1 squared is 1 minus 1 is 0, plus a times negative 1. That's going to be negative a plus b. So now we have these two equations here, and we can solve them for a and b. If we add them together, we'll get 0 equals, the a's will cancel out, and that'll be 2b, which means that b is equal to 0. And if we plug that into the first equation, for example, you get 1 equals a plus 0. That means that a is equal to 1. So our solution is just a times x plus b. So 1 times x plus 0, which is just x. And that is answer C.